Today we're going to look at how to factor quadratic expressions using the method of decomposition. Quadratic expressions, of course, expressions that have a pattern like this: a squared variable, a variable, and a constant. And decomposition is, as I said, it's a method. It'll actually work for any of the different kinds of quadratic expressions that we've looked at, but it's specifically helpful for factoring quadratic expressions when there's this a value out in front, and especially when a is not a square, right? Then it might be a perfect square trinomial, or when a is not a common factor that factors out. So, as you've heard me say many times, it's all about pattern recognition. And so when should you use decomposition? Probably when you see what we have here, with a number in front of the x squared, or the squared variable, that's not a common factor and not a square. So here's an example: 3x squared plus 8x plus 4. And the key to factoring by decomposition is to do the decomposing step, and decomposing, as you know, means breaking down. And what we're going to break down is we're going to break down this middle term into two terms. We're going to keep the first term, and we're going to keep the last term, but the middle term we're going to break down into two terms, right? And so it's got to break down into two things that are going to add to the 8x. Now, the list of things that add to 8x is pretty long, infinitely long, actually. So we're actually going to narrow it down. And this process works when some pretty specific criteria are fulfilled. And that's this. So we have an a number here, it's 3. We have a c number, it's 4. So in our case, we have a equals 3 and c equals 4. The first step in factoring by decomposition is asking ourselves, what does a times c equal, or ac? In this case, ac equals 12. And here we have the most important thing, this b value that we're going to decompose. The two things that we're going to decompose it to also must equal 12 when they're multiplied together. So that means we are looking for two numbers that multiplied together equal the same thing as a times c, so the 12. And of course, because they're being decomposed from 8, they have to add to 8. Okay, well, since we're looking at things that multiply to 12, we'll just make a little list: 1 and 12, 2 and 6, 3 and 4, right? And of course, I guess it could be -1, -12, -2, -6, -3, and -4. But out of these combinations, how many things also add to 8? Well, 1 and 12 don't add to 8 in any way. 3 and 4 don't, but 2 and 6 do. So I think that means that the two numbers that we're looking for are 2 and 6, because 2 and 6 do those two things. That means that over here, we are going to then decompose the 8x to a 2x and a 6x, okay? And for that matter, it didn't matter if we wrote 6x and 2x, it'll work either way. So now we've expanded our trinomial into a 4-term polynomial, which in the last video and in your last exercises you learned how to factor, as long as it does factor by grouping. So that's what we're going to do. We're going to look at these first two terms and say, hey, there's a common factor of x here, and that leaves a 3x and a 2. And in these two terms, we're going to say there's a factor of 2x, common factor of 2x, that leaves a sorry, not 2x, just 2. And that leaves a 3x and a 2. And just like in factoring by grouping, we look at these two things and say, hey, are they the same? Are they the same? And if they are the same, then we're probably on the right track. And so we just finish off by saying that this factors down to x plus 2 and 3x plus 2. And there we go. We could check it. Does that work when we actually FOIL it up? 3x squared plus 2x plus 6x is 8x and 4. So we must have factored it correctly using the method of decomposition. Just really quickly, what would have happened if we had done 6x plus 2x instead of 2x plus 6x? Well, let's see. 3x squared plus 6x plus 2x plus 4. Take out a 3x here, and we're left with x plus 2, take out a 2 here, and we're left with x plus 2, and we would get the same two factors. So looks like either way it'll work out. So steps are determine a times c, and then pick two numbers that add to b and multiply to ac. Okay, another example. This is a candidate for factoring by decomposition because this 6 is here. It's not a perfect square. It's not a common factor. By the way, we could even if this was a 1, if there wasn't a number here, you could still factor it by decomposition, but you wouldn't want to. You would just factor that using simple quadratic. Okay, so step 1, determine what a times c is. 6 times 1 is 6. So I'm looking for numbers that also multiply to 6 but add to negative 5x, right? Well, the list of things that multiply to 6 is not very long. 1 and 6, and 2 and 3. Right? Now, this is a negative 5 here, which means that probably, since this is a positive, I must be looking for two negative numbers, because the only way I can get a positive 6 is by multiplying two negative numbers or two positive numbers together. So, I think that the 2 and the 3 will work. Here we go. 6x squared minus 2x minus 3x plus 1. I've decomposed the 5 into two terms that add to the negative 5 and also multiply to the same thing as the 6 times 1. Factor by decomposition, 2x, 3x minus 1. And now here I have an interesting thing. I got this minus 3x plus 1. There's no common factor here, but because there's a minus here, I think I'm going to factor out that minus, and I might even call it a minus 1 instead. So if I'm careful and factor out a negative from a plus 1, I'm left with a minus 1. And again, if these two are the same, I can continue to factor by grouping and finish off with 2x minus 1 and 3x minus 1. Quick check, that equals, if I FOIL it, 6x squared minus 2x minus 3x, which is minus 5x, and plus 1 looks good. Here's another quadratic expression to try factoring. I'd recommend maybe you give it a try before you see exactly how it works out. So maybe pause the video for a minute and give it a shot. Okay, well, we're going to decompose the middle term. Right, and we're going to decompose that minus 3 into two things that add to the negative 3, of course, and multiply to the same thing as a times c, so it must multiply to negative 40. So things that multiply to 40, 1 and 40, 2 and 20, 3 and nothing, 4 and 10, 5 and 8, and I guess that's about it. So some combination that adds to negative 3, and I think here's the one that does. So 10a squared, it will have to be minus 8ab and plus 5ab minus 4b squared. Factor by grouping. Common factor here is 2a, and I get a 5a minus 4b, and common factor of just a b, I guess. 5a minus 4b. Things are looking good because I have the same common factor there. And I think that's correct. Just a quick check. 10a squared minus 8 plus 5 is minus 3ab and minus 4b squared. Great. So here's two last examples of some quadratic expressions that we could factor using decomposition. But you can see that these numbers are getting a little bit bigger, right? We've got a 3 and a negative 60. That means that AC would equal negative 180. Over here we've got a 9 and a 16. I guess that means that AC would equal 144. So breaking up that middle term is going to be a little bit challenging, right? Things that add to negative 3 and multiply to negative 180. Things that add to 24 and multiply to 144. But it's doable. Let's see what we come up with here. And there we go. We've broken up the middle term here successfully. We've broken up the middle term here successfully because negative 15 times 12 is negative 180. 12 times 12 is 144. And there's just a couple steps left. Factor by grouping and finish off. There's the factor by grouping step. And there's the factored step. Now I do notice that over here, 3m and 12, inside this factor I have a common factor. So I have to take that out. I'm going to take a common factor of 3 out of that. And it will be 3m plus 4 and m minus 5. And I do notice on the other side here that I have the same thing twice. So maybe I'll just write it that way. And so we've successfully factored both of these expressions by decomposition, but actually the main reason I wanted to do this one and this one is that these are two that could be easily, and actually much more easily factored if we recognize the pattern. Let me just show you what I'm talking about. If I was given this expression, anytime I'm looking to factor whatever it is, I should take a look and see first, is there a common factor? And that would have saved me a lot of time. Because, yes, there is a common factor of 3m squared minus m minus 20. And what I'm left with here is just simple quadratic factoring. And that's a 15-second problem at most, right? Two numbers that multiply to negative 20 and add to negative 1. I know what those are. It must be 3 and m minus 5 and m plus 4. Much faster process if I recognize. And what did I need to recognize this time? Recognize that there was a common factor. Here on the other side, it took me a while to figure out what are the things, first of all, what does 9 times 16 multiply to, and what are the things that multiply to it. Instead of this, 2-minute problem, this is actually a 10-second problem if I recognize. What do I need to recognize in this one? I need to recognize that 9p squared is a square, 16 is a square. This guy here is a perfect square trinomial. How do perfect square trinomials factor? Always like this. 9p squared is the square of 3p. 16 is the square of 4, and it's all done already. So, again, recognize, so important, saves so much time. Everything is factorable using decomposition, but it's not always the most efficient way to go. Like I said, though, it does always work, and it's just something that you're going to want to get good, efficient, and accurate at.